Welcome to rolling races. Today we're going to show you what happens when we race objects that are similar in one way or another but have different moments of inertia. So we're going to start, we went and bought a set that is supposed to have the radii exactly the same, and you can see all three of these sets have the radii exactly the same. And this set is very special. It's supposed to have exactly the same masses. So of course we went ahead and measured the masses, and what we find is the first one is measuring at about 523 grams. And so we were hoping that the second one would be exactly that, but of course it isn't. And we had to adjust it a little bit. It ended up coming out a little bit higher, 541. And in physics, this is often the case. We say things are equal when they're close. And that's always an issue that you have with experimental error. These two mass ratios are actually quite close to one another. So now we're going to try the race between them, and we're going to see which one wins. Before we start the race, however, you should make a prediction. I think you've already made the prediction in the calculations. If you haven't, please pause and go back to do that. But if you have, just remember what your prediction is, and then we'll see whether or not it works. So as you can see, the hoop took a longer period of time. Now we're going to do the same thing with the other sets. We're now going to be comparing three different ones. These all have the same size, but their masses are quite different between them. They weren't set up to have the same overall masses. So we have a sphere, we have a disk, and we have a hoop. And it was a close race, but I hope you saw that the sphere won, just distancing out the disk, and all of them clearly beating the hoop. And we can do this again with the larger set. I believe this is made from the same manufacturer, at least looks like it is. And it's just a larger size, but the masses are not the same in this case. And we got the same result. It didn't depend on what the size of the different objects were. We can do it one more time, just to make sure we got the right result. All right, now since we have these nice three sets, we can mix and match and play some games and see what happens if we race two hoops together that have different sizes. What happens when we do two disks that have different sizes? So now we're going to first start by looking at two hoops and checking to see which one wins. As you can see, it's all a little bit difficult to get the ratios exactly the same, but what you can see is they're both arriving at about the same time. So we can do a similar thing with the two solid disks. And one of the questions you might ask in this case is, where should we be lining them up? Should we line them up at the centers, or should we line them up on the sides? It's a little bit hard to tell. We've been lining them up on the centers, and you can see that they're not arriving at exactly the same time, but it's pretty close.